Okay, hello everybody. It is time. It's 4:40 here in the UK. It's 5:40 in Oslo. Sadly, can't be in Oslo today. It's a real shame. I always look forward to NDC Oslo every year, and I've been going for many years. My name is Martin Beeby. I'm a principal developer advocate at AWS, and today I'm going to be talking to you about building a real-time serverless application in Blazor using AWS. If you want to contact me, I'm at the Beebs on Twitter. You can see me quarter of the way down that screen there at the Beebs. If you've got any questions or anything which come to mind after this, or if you're watching the video replay of this, then please just tweet me at that address and give me any questions that you have, and I'll get back to you. Also, if you have any requirements for a free trial of AWS, or you want some credits for AWS, I can give you a $50 trial for AWS. Just tweet me or DM me at the Beebs, and I will set you up with that. So without any further ado, let's talk a little bit about building real-time serverless applications in Blazor using AWS. So we're going to be showing you what I'm talking about in terms of what a real-time application is, because there's lots of different definitions for it. So I just want to level set what I'm talking about. I'm going to show you how you could build those sorts of things with SignalR. And then I'm going to be showing you how you could build those sorts of things using serverless technology. And in particular, we'll be using the Lambda service from AWS using C#. And then finally, I'm going to show you how you sort of combine them all to build a serverless and Blazor application. And one of the advantages of doing that, and the whole reason for doing that, is basically the costs involved. So to build the SignalR application and to have it working at a certain scale is going to cost me probably hundreds of pounds a month, hundreds of euros a month to run. Whereas the serverless application will only cost me, well, it'll cost me very, very little, but more importantly, I actually only pay for the times that it's being invoked and being used. So if someone actually makes a request on my application, then I'm actually paying per request rather than paying sort of for the infrastructure which is just sitting there. So there's the reason I'm moving this to a serverless rather than just being a standard real-time application is to try and save money fundamentally. So when I talk about real-time applications, there's lots of different types of applications that are real-time. And the common example would be something like a chat application. So something like WhatsApp. When you're texting and you're sending a text message to somebody, that message is obviously being delivered in real time so that they're able to converse and be able to chat. But also things that aren't so obvious are also being done in real time as well. So things like notifications, things like little read notifications, like the double tick in WhatsApp, which shows you that someone's read your message. That's a real-time notification which is happening. Some event is happening in the real world, and you're being alerted to that event happening and taking place with the double tick. And also, when someone's typing a message in WhatsApp, there's a really irritating signal sent to the other user to say that person's typing, so they can be expecting that sort of stuff. So you'll see it in lots of different styles of application, from a news website when a breaking news story hits. We're maybe sending that, we're pushing that data out to the users in their browser, so it pops up as a little pop-up. Now, to do that, we need some way of pushing data from the server to the actual client user. And that's what a real-time application is really. It's an application that not only you can browse and you can look at information, but it can receive events coming in from the real world. So if a breaking news story breaks, then that can alert your application, and then the UI can respond by popping up some information that is a breaking news story. Multiplayer games, so if you've ever used massive multiplayer online games, and other characters, their health, their position in the game, all of that stuff is being relayed to you in real time, probably using some of or similar real-time technology like the ones we're going to be showing you today. Document collaboration, I use things like Quip or Google Docs. When you're editing a document and someone else is participating with that editing, they're doing that in real time, and they're using real-time web technologies. And we'll sort of take a look at a couple of those. So here's an example on Booking.com. I haven't actually had to book a hotel in an awful long time. So this is, but if you go to something like booking.com and you were looking at a particular hotel, you'll note that at a certain point in your journey, they pop up a little message like this, and it says, just booked in London, 52 properties like this Hilton in London. And there's a number of ways they could implement this, right? They could implement this on a timer. So, after 15 seconds of browsing a property, they could just put up this UI. But what I'd like to think is that they're doing this in real time, that someone actually physically really booked this particular hotel, and that they're showing you that in the UI. Now, I don't know if that's exactly what they are doing in this scenario, but it's an example of a real-time interaction, and it's trying to drive the user to go and book this hotel because they're getting this impression that it's being booked all the time. Maybe they're not able to get a room and so forth. But something's happened somewhere else, and the server sent an event down to the browser to say that someone's just booked that particular property, and then the UI has responded accordingly. We use a document collaboration system at AWS called Quip. I think it's by Salesforce, and it's a bit like Google Docs, I guess. And one of the cool things that I really like about this application is that you can view who's viewing the document. And this is really useful if you send out a document. We have this thing in AWS where we send out the document and we read the document during the meeting. It's a peculiarity of the way that Amazon works. So we'll all send a document out at the start of the meeting, and then we read it for like 10 minutes, and then we get on with the rest of the meeting, knowing that everyone's on the same page and everyone's definitely read the document before we start discussing it. Now, one of the cool things is about the viewing thing is that you can actually see that other people are connected to the document and they're viewing it, they're reading it. So you know that they've received the link for the document. You can see that if there's 6 people in the meeting, you can see that 6 people are viewing the document. They've all managed to get access to the document, that sort of thing. Also, it has things like there's a chat functionality in Quip, and it even has that really annoying UI about typing, where someone, as they're typing, it shows you, oh, Ron Swanson's typing, and you can sort of it's indicated in real time that they're doing that. Now, if you think about what's happening when that user is pressing keys on their keyboard in that particular message box, that's sending a signal to a server somewhere. Then that server is then relaying it to everybody which is viewing that document that someone particular is typing. So this is an example of a real-time event, something happening in the real world, being relayed to multiple people in real time to give a better experience for that user. But this is a particularly annoying UI, because what I always find is someone starts typing and you go, oh, what are they typing? So you're waiting, and then they delete the message. And then oh, for goodness. Right, so there's certain anti-patterns perhaps to real-time applications, but it's a useful piece of user interface which is developing. So the vast majority of applications today are going to be using WebSockets to achieve this real-time application. Now, that's whether they're a browser-based application or whether they are a mobile phone application or even an IoT application. They'll probably be using something like WebSockets, or in fact, they'll be using WebSockets to communicate. Now, WebSockets is a protocol which allows us to send messages not only to a server, but receive them back from a server. And that's really something which HTTP isn't capable of. You can send a HTTP message to a server and make a request, and it gives you a response. But the server then can't, at a later stage, send you something else. It's a one-time thing. And the request always comes from the user making a request of the page or the web server. The server can't ever make a request back to the user. Well, WebSocket solves that problem by basically creating or instantiating a pipe between the server and the application, by which communications can travel back and forth. And the good thing about WebSockets is once you've got the pipe set up, there's no serious overheads in terms of the data which is being transmitted. So with a HTTP request, every time you make a HTTP request, you have to send over the cookies, you have to send over the headers, you have to, there's lots of stuff other than just the request which goes through. But with a WebSocket connection, you can just send literally the data. Once it's started and negotiated and set up, then data can freely transfer between the app and the server, or more importantly, from the server directly to the app. Now, a WebSocket negotiation happens something like this. You make a HTTP request to the server, and it's a specifically crafted HTTP request. It's called negotiation handshake. And it says basically to the server, do you support WebSockets? And the web server replies, look, it's 2020. Of course I do. That wasn't always the case. Years ago, there's absolutely servers and application frameworks which did not support WebSockets. But in almost all scenarios nowadays, you'll find that mostly the clients and mostly the servers will basically support WebSockets. And because they both sides of this equation support WebSockets, and both sides have to be able to support WebSockets to enable it, they will be able to create a new pipe which they can communicate between each other. So when I got into real-time applications or building real-time applications, it was sort of around 2008, 2009 time. And I was using a framework, or I got into a framework called SignalR. Now, SignalR is an incredible framework for building these sorts of real-time applications. And it means that you don't really need very much understanding of how WebSockets work. You can program in C#, and it's got a really nice sort of developer abstraction over the top of it, and it makes it very simple to write sort of applications. It's an open source framework. You can still use it today. You can use it in .NET the full framework .NET, or you can use it in .NET Core as well. It is open source, as I say, and it supports a number of different transports. So I've talked about WebSockets. There are other transports that I'm not going to go into, but there are other ways of doing real-time communication. And SignalR is really nice in that it wraps them all up for you and basically chooses whichever is the best option at the time, depending on what the server supports, what the application supports, and various other things. It's not a talk about SignalR, but it's just an important thing to sort of explain what I'm trying to build here. Because when I built my SignalR application and I moved to AWS, which is about 1.5 years ago, I decided to see how I could deploy a SignalR application on AWS. Now, the simplest service at AWS, I'd say, to publish a .NET application is a service called Amazon Elastic Beanstalk. And what that does is, if you're on Visual Studio, let's say, you can build a .NET application, .NET Full Framework or .NET Core, and you build it, and if you have the AWS SDK installed, you can right-click the project and you can say, deploy to Elastic Beanstalk. And what it will do is it will wrap up your code, build your code, put it into a zip file effectively, and in the background, it posts that to AWS, and then AWS takes that code and it puts it on some infrastructure. Now, the infrastructure that you set up, you can say, I want 1 server, or I can want 10 servers. I want it to auto scale between 1 and 10 servers. I want a load balancer in front of it. You make all those decisions when you're doing the deployment, and then it will basically put the web application on however many servers that you want. So I took my SignalR application, I stick it on, I build it using Elastic Beanstalk. Because it's easy, I use the Visual Studio way of doing it, but you can easily do it from command line as well. But I say, okay, publish it to Beanstalk, and what it does, it creates a load balancer for me, and it creates 2 instances. So I've got 2 instances, 2 web servers. In AWS, we call those instances. 2 instances, each running my application, and a load balancer, which load balances between the 2. Now, the only thing that I had to change really to get this working was to say, well, the load balancer, that needs to be sticky sessions. Because the way SignalR works, once a web connection is set up, a WebSocket connection is set up, you want the person going back to the same web server. So I set up sticky sessions on the load balancer, and pretty much my application works. So just to show you what that application looks like, if you have a mobile phone and you have a camera, or if you just want to punch in the URL signalr.thebeebs.net, and but I'm going to just scan it with my camera, this QR code, and it will take me to the URL, and I should then receive like a little thing which says, please wait. So it's like a little gray screen. So once a couple of you people have gone to that site, then what I will be able to do is I should be able to go and click through to the next thing. And what will happen is my phone will have been updated with a question. It says, what drink, coffee or beer? And I see a few of you have already started to vote. and 5 of you saying coffee, 6 saying beer. I'm going to vote for coffee. I don't drink. 6 and 6. So today at NDC we've got like 6, 7. Oh, actually, coffee's taking the lead. There's people voting for coffee and beer using the application, and you'll see that as you press the button on the application, it sends a signal that's received by the application. It updates the counter on one of the sides, right? Now, if I go over to tabs versus spaces, interesting. Never mind. I don't know what went wrong there, but you can vote versus tabs versus spaces, and we can see. Oh, before it crashed out, I don't know why it was doing that, but never mind. We're roughly, I'm generally going to say that tabs are winning for some reason. I'm going to take it off that screen for some reason because it's not quite working how I expect it to. Luckily, the SignalR demo is not actually what I was going to show today, so that's good. But roughly what's happening there, the idea is we've got our load balancer, we've got our 2 instances, and it's balancing between the 2. Application's working. As you connect to it, you're connecting to one of those 2 instances, and all should be kind of well with that. But there is a slight problem. Because we have 2 instances and we have messages going back and forth on WebSockets, when I vote, the voting doesn't always happen on the message doesn't always get sent to both machines. You see, when I say I'm voting or incrementing a number to say I want to vote for coffee, that message only gets sent to the server that I'm connected to. It doesn't get distributed to the other servers. And so this is a common problem in real-time applications. If you've got a number of servers which are in a application, then they actually need to talk to each other as well to be able to pass the messages back and forth, so that you've got the correct messages going to so the application's functioning correctly as a sort of unit rather than as individual applications separated. Now, the way that we solve this in something like SignalR and in many sort of common scenarios is we use a thing called a backplane. And a backplane is basically some kind of mechanism which stands behind the application, which we can communicate, so the servers can cross-communicate and pass the messages back and forth so that everyone's got the correct messages in the real-time applications. And now, to do that on AWS, okay, now I would have to go and set up a backplane. And SignalR, the preferred backplane for SignalR is something called Redis. We have a service at AWS called Amazon Elasticache for Redis, which is basically a managed Redis service. So I can stand up a managed Redis service, and it's set up as my backplane. Once I've basically created that thing, I go into my .NET Core application, and all I have to do is actually add this one line of code or a couple of lines of code, which says on my SignalR installation .add Stack Exchange Redis, and then I pass the connection string to my Redis cluster, and then I set up a channel prefix, which basically means the communications for this particular my application is going to communicate on this particular channel called myapp, and then basically that's really all you have to do to set up the backplane in SignalR. SignalR takes a lot of the complication out of something like this. But there is a challenge with this now. Okay, I've wanted to build a simple real-time application, and all of a sudden, I've got a load balancer, I've got 2 machines, I've maybe got 10 machines, and then I've got to have a backplane, which is a cluster of machines running Redis. All of a sudden, this is starting to get quite expensive. So to do a demo like I did before, where I had 1 or 2 machines, it's not very expensive to run something like that. But when you're actually scaling this, if you wanted to build Facebook Messenger on this infrastructure, or some kind of chat application where you're expecting hundreds or thousands of people to be communicating at one time, or you're building a real-time news application which is doing updates in the browser of real-time events happening, then you're going to have to scale this infrastructure pretty hard, and it's going to be expensive and it's going to be complicated. So I was kind of wondering, well, is there an easier way? And a few years ago, AWS released a thing called the API Gateway WebSockets, and this is what I'm going to be integrating today into a Blazor application. So API Gateway and WebSockets is basically API Gateway is almost like a thing which just stands up in the cloud, and you can send messages to it, and it will route those messages to other systems. So you can think of it as like a gateway for your API. I don't know why I said that. You can think of it as like something you put in front of your application to provide an API or a unified endpoint to your application. Your application doesn't have to be one single application. It could be multiple applications, but you're unifying them through this API gateway. So that's what API gateway was commonly used for, but then they added this support for WebSockets. And what that means is that you can basically, not only can you manage, use it as like for an API, you can also deal with WebSockets communication. And what they're promising is basically, we'll manage all of the WebSocket communication stuff for you, and you just implement your application as you would normally, and we will maintain all the connections for the clients, and we'll set up a system where you can post to all of your connected clients. But it's much more straightforward than having to deal with WebSockets natively. So let's explain a little bit more about what this means. So we have application or things like mobile applications, chat applications, dashboards, IoT devices, web browsers, which connect to our API gateway. And so they connect to a WebSocket endpoint and a WebSocket URL. And then in the back end, we have our infrastructure. Now, I'm going to be building using serverless infrastructure. So I'm going to be using Lambda functions in the background. But these could be containers. They could be an existing API, whatever really. API gateway can forward onto any kind of other system. But I'm going to set up a WebSocket system, and then I'm going to forward it to some Lambda functions. So what happens is the mobile application is just going to use this standard WebSocket client that it has in its SDK, and it's going to connect to a WebSocket endpoint that the Amazon API gateway is going to provide. So that's going to be like WSS://. So instead of HTTPS or HTTP, it's going to say WSS, which is basically a WebSocket a secure WebSocket. You'll sometimes see a WS://. That's just a WebSocket. But a WebSocket:// a secure WebSocket, then it's going to have a unique ID, execute.api, then the region that this is running in. So if I was using it in EU West 1, it would say EU West 1 there, .amazon.com / and then the name of the stage that you're using. You can create in the APIs different stages, whether they be prod, dev, or test, or something like that. I often will just use the stage name prod because I like pushing everything to production. And what happens is these devices connect to the API gateway, and they just set up a WebSocket connection between the two. But API gateway, when it receives a message over the WebSocket, it just invokes whatever's on the back end, like a RESTful communication. It doesn't do it over WebSockets, it just invokes it. It invokes it and it passes over to the invocation a connection ID. And the idea is that because you're being invoked and you've got a connection ID, if you want to speak back to that connection, you have this ID that you could call at a later date. So you have this duplex communication set up. But it's important to remember that the Lambda functions themselves have no idea that they're involved in a real-time application. They are just dumb Lambda functions. And they're receiving an invocation with a connection ID. And if they want to, they can respond to that connection ID. What I actually do when someone connects to this system, they pass over their connection ID, I put it into a database. In this instance, we're using DynamoDB. And basically, anyone which connects to my WebSocket, I put their ID into a database. And then we have a way of taking those IDs out of the database and calling them and basically sending a message to everyone. So we're able to send messages to everyone which is currently connected to our system. Basically, if I loop over the database and all the connection IDs, and I use this particular URL with this connection ID crafted on it, I can post messages to the individuals. Now, I'm actually not posting messages to the individual people. What I'm doing is I'm posting a message back to the Amazon API gateway, and then that's then forwarding it on to the correct connection. So from an endpoint user point of view, they've got this real-time communication happening, but the reality is the magic's all happening in the API gateway. It's the one which is maintaining the connections. It's the one which is understanding or creating connection IDs and matching them back up and passaging messages messages back and forth. So we have this thing called the WebSocket URL, and as a message is being sent to the API gateway, it invokes the Lambda function, and we store some of that in DynamoDB. Let's say now we want to do the opposite way. We want the server to be able to message the client. Now, I mentioned before, I can have a Lambda function which basically goes into all of my DynamoDB database. It gets a list of all of the connection IDs, and then it posts something to each of those connections. The way it posts to them is that just use a connection URL. It's called a connection URL. It's got a random number, the region number, and then here at the end, a really important bit, which is the connection ID. And if you do a post to that connection ID, then you can send a message to it, and it will get routed by API gateway back to the person which invoked it, right? Now, the connection URL has a couple of methods on it. We can post to it, which is send a message to that particular user. We can do a get on it, which basically gives us the status of that current user, or we can delete it, which removes that user from our system, or basically disconnects their socket URL, their WebSocket. So if we wanted to create one of these APIs, we go into AWS console and we create a WebSocket API. We give the API a name, my fancy NDC API. We give it a thing called a route selection expression. This is basically what the API gateway is going to use to route the messages coming in to different Lambda functions. And then once I have that created, there we go. Once I have the API created, you'll see that there's a couple of routes already set up. So what we can do is we can say we're going to connect this particular route to a Lambda function. And we're going to I've got some Lambda functions already set up. One called onConnect. I'm going to set up the disconnect one as well. There's a Lambda function which happens or is called when anyone called disconnect to this service. And we're going to create a new route called send message. And we're going to put that into a Lambda function called send message. So I've got 3 functions, Lambda functions, and one API gateway. Deploy that API. Give your stage a name. You can have as many stages as you like. I'll call one called prod. It's my production API. And deploy that. And then you'll see we have this WebSocket URL and we have a connection URL. So a URL for that particular connection. So the WebSocket URL is what we would use inside of our application to instantiate or create a WebSocket communication to our application. And the connection URL is if we have a connection ID or a number of connection ID, we can basically post to those connection IDs and send messages to the different people connected to our service. So my application, what it does is it crafts this particular, this sort of payload. And this is what the message it passes through the WebSocket. And when I pass this message, you'll see that it's got this one property called message, send message. Now, message is what it's actually going to be routed on. So it's like the root key. So if I pass this, it's going to be, my API gateway is going to receive it as a WebSocket request. And it's going to say, okay, send message, let me go and route that to the send message Lambda function. It doesn't have to be a Lambda function. I could have routed it to an API endpoint, which is backed by an IIS web server. I could, it doesn't have to be a Lambda function, but I'm going to post it to this Lambda function, and that's the connections that I've made. And the data that I'm going to pass over is just saying hello NDC. Now, this doesn't have to just be such a simple package. It could have multiple things in here. It doesn't even actually need to be JSON, but that helps with the scenario we're doing. So I'm going to just say I want a message with send message, and if I posted this to that particular WebSocket URL, then I would have posted a message and it would get routed to my Lambda function called send function. this is the way that my sort of architecture looks in this scenario. We have the Amazon API gateway, the client application. Now, the client application can be really dumb. It can just be a HTML page, a very straightforward, inexpensive static website, and that's just going to create a WebSocket, and then that will connect it up to API gateway. And then as I send messages to it, it's going to route those messages to the correct Lambda functions. Now, when I instantiate a connection, the first thing that's going to happen when I instantiate a WebSocket communication, by default, the thing that gets passed is onConnect. So what happens is it will go to the onConnect Lambda function. Now, my onConnect Lambda function, what it does is it takes the connection ID which is passed to it and it stores it in DynamoDB. I also have a Lambda onDisconnect function. And so whenever someone disconnects from the WebSocket, it will automatically send a message to that, which basically says, hey, this is an ID which is no longer connected to the service. And what that function does is it goes into the database and it removes that connection ID. The point being, my DynamoDB should have a list of connection IDs at any given point of everyone connected to my application. Now, I'm using DynamoDB as a storage, but this could be any kind of cache, really. What send message is doing then as well is once someone makes a message and crafts it in that particular way so that it uses the send message functionality, it will go to the DynamoDB, it will download all of the current connected clients, it will send the message to each of those connected clients, and so everyone receives the message. So this is, I won't go too much into the code because I have it on GitHub and I can share it later. It'll be easier probably to look at there. But basically, this is the send message function. Now, the send message function, what it's doing, it's got some logging in and so forth here. But we're taking this property, the data property, which is the message, and we're putting it into a stream. And then we're asking for, this is the way that we go and get all of the items inside of DynamoDB. DynamoDB, by the way, is a NoSQL database, very performant, quite well suited for this kind of task. And it basically does a scan and says, give me back all of the connection IDs. And once I've got those connection IDs, what I can do is I can loop through them. So for each item in those connection IDs, and for each of those, what I'm ultimately doing is I'm posting the message to the connection. So I use this little helper function to actually create the URL for me and create the connection URLs for me. But ultimately, I'm basically looping through. If there's 500 people connected to my service, I'll loop through those 500 people and I'll send them all a message via a post, effectively. So let's just show you what that ends up looking like. So if I go to a website called chat.thebeebs.net, you'll see it's pre-pitted with a URL, or it's already got a URL in there. And I can connect to that URL. I should be able to connect, yeah. And if you go to chat.thebeebs.net as well, you can join in with this fun too. Let me go and set up another browser. Connect it up. And if I type in hello there, that's odd. Oh, yeah, I received a message which is hello, which is what I sent, and someone else has sent a message for it as well. And then on the other side, you can see, so I can say window 1, send message. And over here, window 1, and I can say window 2 over here. And someone said, hey, there as well. So people are connecting to this application, and it's basically a very, very straightforward and simple application. It's using that connectivity back in the background. Now, I think, if you go to my GitHub, GitHub, the Beebs, sorry, I can't remember the name of the repository. Is it this one? Yeah. So the actual code which is running on the screen there is just a simple HTML page. It's super straightforward. It's built in, did I build this in Vue? I can't remember. If I look at the JavaScript, you'll see that I have a a connect function, a disconnect function, and a send message function, and it's just basically crafting these send messages, just crafting a thing, say send message, and then passing some data across. On connect is just setting up a WebSocket connection. And yeah, I'm using Vue there to kind of update the scenario in the screen. So that's the code to kind of enable that. But it's all in JavaScript. And I'm talking about something else today, aren't we? We're talking about Blazor. So how would you go ahead and kind of do something in similar, but let's do it in Blazor. Now, in Blazor, we've got two different ways of running Blazor. We've got a thing called Blazor WebAssembly. And we've got a thing called Blazor Server. Now, I'm not going to be talking at all about Blazor Server today. I'm going to be talking about Blazor WebAssembly. And the reason is because Blazor WebAssembly is better suited for what I'm trying to do here. What I want is to create basically a Vue.js style web application or a React style web application, but I don't want to use JavaScript. I want to use as much .NET as possible. So I'm going to be using Blazor WebAssembly. And what it allows me to do is create like UIs, using web technologies, but all of the logic isn't written in JavaScript, it's all written in .NET. And behind the scenes, what Blazor is doing is it's using WebAssembly to run your C# application. WebAssembly is a new feature of browsers, and it's kind of this weird way of being able to execute things or run things which it previously wasn't able to do. And some clever people have decided that we could actually run other programming languages inside browsers now. And Blazor is basically, Blazor WebAssembly is that. It's a really clever little framework for building web applications, but using C#. Now, this doesn't mean that we're going to be using any kinds of plugins. This is not Silverlight. It's just using native web technologies. It will only obviously work in browsers that support WebAssembly, but nowadays that is almost every major browser. But it wouldn't obviously work if you're still supporting IE9, this won't work. But the Blazor servers are a similar thing, and basically you can take the same application, but this would work in something which is a much older browser, but it requires the server to be doing a lot of the processing, and it actually uses WebSockets in the background to achieve the Blazor server hosting model. But we're not going to talk about Blazor server. It's interesting, but I've already pretty much run out of time for that. So we're just going to talk about Blazor WebAssembly. And what I was kind of looking at is, well, how do I port that first application I built into something like Blazor? Now, I haven't quite got the style the same. It's just purely technically how I would go about and do it. And this is a road that I started down about 9 months ago. And I've gradually kind of like revisited the application as Blazor's matured and added new features to it and got it to a point where I think it kind of does everything that the Vue.js application does. It just doesn't quite look as pretty. That's another job that I need to do. So to start with Blazor, we just go to the Blazor site. There's a little getting started application documentation. If you click on that, it's going to tell you to install .NET 3 point whatever it is nowadays. And then once you've done that with the .NET command line, you can say .NET new Blazor WASM. That's Blazor WebAssembly. And then we give it an output like a name for our project, which is Blazor front end in this instance. And then I CD into that folder, and then you can just say .NET run, and it will build your application. And it's got a very sort of basic application where you can click a ticker, and it will update a number and increment a number. The cool thing is, everything in that browser, all of the logic isn't done in JavaScript, it's all done in .NET. So in my application, I've basically tried to use that base application as much as possible, and I've made a few modifications to it. So one, I've added a question.json file with sample data. So my questions at the moment are just hard coded into the application. Obviously, I won't do that in the real application. And I've got like a question ID 0 and a question ID 1, and it's got tabs or spaces and coffee and beer. And so this is roughly the data that in my real application, I actually store in a database, but I'm going to be just storing it locally here. And I have a couple of pages that I've added. I've got the index page, a page called questions, and a page called vote. Again, it's similar to my application. I have like a voting screen. So if you went and voted a moment ago using the application, that was a voting screen that you'd see, please wait, and then you choose one of the two options and so forth. That's the voting screen. And the question screen is the screen that I present to you, which shows you the QR code and then shows you as you move the slides or you move the questions. And so those are the two kind of like screens in our system effectively. So I've added those as Razor pages. Now, the first thing I do in the questions.razor view is we have this event which says protected override async task on initialized async. So there's this kind of workflow in a life cycle, I suppose, in a Blazor application. And the first thing, when someone navigates to the questions page, it's going to invoke this on initialized async task. Now, I have just very lazily placed the first thing that it does is it loads whatever was in my questions.json locally. That's a local file, but it could obviously just pull this from, you know, a database or another API, and it loads it into an object called questions. Now, questions is basically a list of this type of questions. So I end up with a list of questions. Now, if you've ever used single page applications before, you'll know that the whole point of them really is that you can sort of create a state. So I can have an application state, and my UI automatically updates and reflects that. So I don't actually have to manually bind my objects to my state. So now I've got a list of questions. I can basically create a UI which loops through those questions. So here in my Razor view is the view which displays those questions. So I've got if the questions are null, so there's nothing in the questions, then show a screen which just says loading. Else, print a table, and the table's got title, answer 1, answer 2, answer 1 count, answer 2 count. Now in the real application, I use some more fancy graphics to display the images, to have that little graph in the middle. But for this purposes of this, I'm just going to print it out to a table so you can see what's going on. And so at the top there, we've got the questions. The thing that I'm injecting there, you'll see at the top, is the HTTP client. This is how we do dependency injection in Blazor. We can also import NuGet packages. If we want NuGet packages in the top there, we could, if we wanted to use Newtonsoft JSON or something like that, then you can just import that like you would in a C# file. It's got a little slightly different syntax, but it's ultimately what you're doing. Or third-party libraries, you can import them. And then you can use them inside of your application. So I'm saying, okay, show me the loading screen if the questions is null, but then show me the table. And that table has some logic in it which says, for each question in question, so it's looping through all of the questions that I have. In this instance, I've got 2. And it's saying, if I equals current count on line 27, then show that question. So I've got a really ugly way of basically saying, loop through all the questions and only show the one that it's currently set to. And I've just got a variable called current count, which is basically an integer, which is just going to be 0 or 1 in this application. And if it's 0, it will show the first question. If it's 1, it will show the second question. And if I had 10 questions, it obviously would increment and only show that particular question. And then at the bottom, I have these buttons, and it says on click that button, then execute a C# handler called previous question or one called next question. So you'll see these are HTML buttons, and they've got these 2 values in them, but they're just buttons. And this is a sort of like a decoration that you can put on Blazor objects to say, invoke some C#. And then the actual handlers, well, they just look like C# handlers. We've got a next question and a previous question. Now, I said before, the logic's really driven by what the current count value is, because as I change the current count value, that view is going to alter. You can imagine every time that you alter the application state, it will update the UI automatically. So all I actually have to do is alter the current count variable to be either 0 or 1, and it will effectively be switching the questions. The view will look like the questions got switched. So I just have a next question and a previous question. It's got some logic basically to say, when I click next question, then increment the current count by 1, but don't go any higher than I have questions. And then previous questions do exactly take 1 off the current count, but don't go lower than 1. So I now can have, with these 2 buttons, I can navigate all of the questions in my application. At the moment, there's just 2. So that's kind of the view that I have. So what this looks like is, if I go to questions now, I've got my question, tabs or spaces, and answer count. And if I click next or previous, it just basically cycles through. What's cool about this is I'm not updating the UI at all. I'm just updating my application state, and the UI is reflecting those changes. So the voting screen is really similar, but all I want to do is basically add some buttons so that they can vote, right? So I've got a very similar sort of setup, but you'll see on line 37 here, I've got a button which says vote answer 1 or vote answer 2. And it shows the information about the question. You'll see that when I loop through the question object, I can access any of the properties of question by just using this syntax, at question.answer1. This is Razor syntax, if you're not familiar with it, if you've never used ASP.NET Pages before. But I can basically create these, I put the title, and then I've got, in the second column, I've got answer 1, and the second column, I've got answer 2 as buttons. And I do actually have, on this version of the application that I built, I had like previous and next buttons, but I don't actually use them in the real application because I don't want users to be able to switch questions. I want that to happen when the slide is changed by the presenter. So now this is the vote screen. It's exactly the same, but I just have effectively buttons there. And what I need to do then is just basically wire those buttons up so that they can vote. Now, this is the very first way that I had to do it. I want to use WebSockets in my application. Now, to get at a WebSocket, I need to the browser to effectively the underlying browser to connect up to my WebSocket URL. Now, at the time when I first started building this, there was no way of doing that in C#. There is now. So I can set up a WebSocket connection, and in C# I can basically deal with the WebSocket all in C#. But this is showing you a mechanism that I had to develop, which is basically called interoperability with JavaScript. So the version I'm going to show you now contains a lot of JavaScript, and it kind of defeats the point of Blazor because I want to stay in C#. All of the bit that I just built, the UI, all of that's in C#, but this bit is going to be in some JavaScript. And I'm not going to go too deeply into the JavaScript because I'm actually going to be able to remove all of this, which is quite cool. But what I've basically said is when the application's initialized, it's going to invoke some JavaScript, which is actually hidden. It's sitting in the index HTML page, and basically connect over to this WebSocket URL. And when you do that, set up a reference, a .NET reference back to this application. And it's still got the same thing when it's connected, it's true. And then it says when R is connected, then so basically it will get a response back from the JavaScript, and then R should be either true or false. And then if it's true, then it will be connected. So this WebSocket's connected. Then I load the sample questions in again. On the HTML page, I had this piece of JavaScript that I'm interoping with. And it looks really similar to, well, it's kind of painful because I've got a connection method, a disconnect method, and a vote method. And basically the way that I'm doing this is I'm invoking this from C#, then C#'s creating the WebSocket, then invoking back the .NET method when a message comes in. And you'll see this .NET object reference invoke method on vote is then invoking a C# method called on vote. And when someone votes, it passes this information across. Now this worked. and I created a new method in my application on my API called vote. And basically now you can send this this data over and say, I want to vote, question ID 1, answer 1. And I was able to get into a scenario where I've created a new serverless function called vote on the server. It looks like this. You can see it later if you want. The important thing is that I had to do this JavaScript interrupt just to be able to use a WebSocket. Now, JavaScript interrupt is really interesting in Blazor because there will be times when you're building web applications that the thing that you want to build just doesn't exist in C#, and you have to invoke or work with JavaScript. So you probably will find yourself having to dip into invoking JavaScript methods from C# in your time when you're developing Blazor applications. But it's cool that we won't have to do this. We don't have to do this anymore. Let's just see what that looks like now. So I've got my application. It's connecting up to this WebSocket. And when I click on answer 1, it sends a message. You can see over here, you can see that there is a message that's being sent over via a WebSocket. And so the person using the vote screen can now vote using that. And so it's being sent to the Lambda function called vote, and then that vote's being broadcast to all the connected clients. The only client that's actually listening to it, though, is the question screen, which is receiving all of the different votes and showing them on the screen as they happen. So now if I basically show that, so I've got on the left-hand side here, I've got the left-hand side, I've got the question screen. On the right-hand side, I've got the vote screen, and you'll see as I'm voting on the right-hand side, it's sending a message over to the question screen, and we'll be able to see like how people are voting. Now, this is just tables, and it looks a little bit ugly, but this is exactly the same logic as I had in my Vue.js application that we used earlier. And you'll see as they're tapping and so forth, then it's updating both sides. So that's the real-time communication stuff is kind of now working. But how do we kind of remove the JavaScript? Well, I actually showed this talk in NDC London, and when I came to looking at Blazor, I was a bit disappointed about how quickly I had to jump into JavaScript to do something which was quite relatively straightforward. You see, when I do that fetch questions beforehand, and we go and make a request to get questions, we're actually using the network stack of the browser to go and get those questions. It's making a request and it's getting routed. Now in C#, we're actually using the HTTP client, but what they've done in the Blazor team, they've kind of intercepted HTTP client and wired it up to the browser so that you can just use HTTP client, and but your network requests are actually getting passed through to the browser. So it's using the networking stack of the browser. So that was really cool for HTTP requests, but WebSockets didn't work like that. We had to use this kind of invoking JavaScript to create WebSockets. But now they've basically done a similar thing. So they've basically intercepted the networking of WebSockets as well. So you can just create a WebSocket as you would do ordinarily if you were building a C# console application and you wanted to add WebSockets to it, or a Xamarin application and you wanted to add WebSockets to it. Well, now you can do that in a Blazor application as well. And basically the networking aspect of it is kind of wired back up to the browser. So you're really using the browser to do the network requests, but it looks and feels like you're using C#. And that's doing it from the C#. So to show you that, I'm going to take you to also a more finished application that I have. So this is the Razor question, questions.razor view. And you will see that instead of invoking JavaScript, what I've got is on the onInitialize screen now, I say await WebSocket.connect async. And obviously I do have at the top here, I have system.net WebSockets. I'm using that library. And I've got a few other things as well that I'm using as well, Newtonsoft.json, system.threading, and various other external things. I'm also using the HTTP client, which I'm having injected. This WebSocket's not being injected. I'm just using the instantiation. I'm creating an instantiation in the page itself. So I'm not using dependency injection. And I'm saying WebSocket.connect async. And I'm passing in a token because you can basically cancel the thing using the token. And then I'm delegating it to receive loop. And what that means is that whenever this WebSocket receives a message, it's going to call receive loop. So that's now this WebSocket is actually now a live WebSocket in my C# application. And I can reference that. Do I use it at all in that page? No, I don't. I do on this one. I've got an echo that I've done. And one of my pages, basically, I can use it in my view. I can say WebSocket.state. And if it's open, then I can show certain things. And if it's closed, I can show other things as well. So you can actually, it's just a C# object then, which you can use in your application. But it's intelligent enough to know what it actually underlying is the network communication for a real WebSocket. So going back to that questions.razor, if I go to this receive loop question, where are we? Receive loop. Let's show you on the vote screen, actually. So I set up the new WebSocket. I call receive loop as a delegate. Basically, when a message gets posted to receive loop on the vote screen, what happens is when the presenter changes the question, the current question which is in view, when they say, well, I want it to be question 1 or question 2, that sends a signal up to the system. The system then broadcasts that message to all of the connected clients. And that message ultimately comes back into this receive loop. And what I do is I go, okay, I'm going to take the WebSocket.receive async information, and I'm going to receive it as text. Now it's actually JSON, so I'm going to cast it as JSON, as a JSON object. I'm going to look for the message part of it. And if it's change question, then I'm basically going to change the question which is currently displayed on the screen. And change question, all that does is, I'll just scroll to it. Change question over here basically changes voted to false, changes current count to the current question, and then calls this thing called status changed. Status change is an interesting one. You don't have to call that all the time. When you make modifications to your objects, they will be reflected in the UI automatically. But because this is using WebSockets, which might be coming back on a different, I think it's coming back on a different thread, or it's not always on the UI. Occasionally, you might have to call status change to just tell your application that it needs to update the UI. I'm not really sure about the built-in stuff about that and why you always have to call it, but I found that I had to call status change to actually update the page. And so what this means now is, let's go and just have a look at one of the browsers. If I go over to the Blazor front end, and I'll take that one over there and just pop that on that side. Oh, there we go. And then if I just take one over here, oh God, why is it doing that? There we go. Sorry about this. So I've got, let's put the vote question on one side and the questions on one. And so hopefully, these connected. Okay. Yes, that is working. As I change the screen on questions, you can see anyone which is connected to the vote screen, the title here is changing as I'm changing the question. So I went to tabs and spaces, but everyone connected is getting the new question, you can see. And then I can answer and so forth, and all of that stuff happens over SignalR. So my actual application, I've just got a couple of minutes to talk about this, is basically broken into a couple of sort of folders. I have my Blazor front end, which is my front end application, which does the WebSocket communications and allows the voting. And then I have a number of projects for each of my Lambda functions. So I have an onConnect function, an onDisconnect function, a send message function, and a slide function. And the way that I actually deploy this application, if I want to deploy it, is there's a file, inside the backend if I want to deploy the Lambda functions. And here is it's a thing called a serverless application model. You don't need to worry about what it is. In Rider, And in Visual Studio, I can do this thing where I just basically right-click on one of these templates and say deploy serverless application. And then the application I can deploy to AWS. So I just say I want to update this and deploy it. Click on deploy, and what it will do is it will build my application and it will then deploy it out to AWS Lambda. And then I'm able to sort of use this and publish it to live. The advantage, I'd say, over using this over the setup that I had before is that this only ever costs me money if someone actually goes to my website and uses it. Otherwise, I don't pay for anything. The way that the costing works with Lambda is that you only pay per request that's being served. You don't pay for the infrastructure which it runs on. So that's kind of it. If you want the code, it's on my GitHub. I'm at the Beebs on GitHub. I'm at the Beebs on Twitter as well. And I'll be developing this application and hopefully get to the same point that they look identical and they operate identically. If you want to help me, then by all means, you can jump on that GitHub and start working on it with me as well. Thank you very much indeed.